Welcome to this lecture. This lecture is the second part of beginning of spectroscopy to the Bohr's model of hydrogen spectrum. So earlier I talked about brief review of spectroscopy, but there is no theory available to explain the spectrum of hydrogen atom. So now here I will start with the experiment of Rutherford and shift towards the Bohr's model to explain the spectrum of hydrogen atom. So in 1911, Rutherford performed an experiment, and that experiment is known as Rutherford gold foil experiment. And on the basis of this experiment, Rutherford tries to explain the structure of atom. I'm not going into the detail of this experiment here. Let me briefly talk about the proposed atomic model. And which is based upon the Rutherford's gold foil experiment. So what he suggested, or what Rutherford proposed, he proposed that atom as a miniature solar system with electron orbiting around the nucleus. And nucleus occupy a very small part of the atom, and nucleus occupy very small part of atom. So that means it's electron. This electron is revolving around the nucleus in a particular direction, and nucleus will be somewhere here. Such type of model was proposed by Rutherford, and at the time of Rutherford, neutron had not been discovered. So that means in his proposed model, he considered the nucleus consisting only of protons, because there is no idea of neutrons. So that means he proposed that nucleus only consisting of protons only, according to Rutherford's model. And this atomic model was failed to explain the, means it was not able to explain the model, failed to explain stability of atom. The main drawback is discussed as follows. So according to this model, Electrons revolve around the nucleus. Around the positively charged nucleus, and this orbiting electron undergo acceleration and this acceleration is due to circular motion. As we know that as I discussed in the course of electrodynamics, that during acceleration charged particle would radiate energy and this leads to collapse of electron into the nucleus. Then this model of atom also failed to explain the existence of definite lines in the spectrum of hydrogen atom. Then in 1913, Niels Bohr inspired by the work of Einstein and Rutherford's atomic model and he formulated the following postulates. So first is the existence of stationary states. Existence of stationary states an atomic system can exist in certain stationary states each corresponding to definite value of energy E of the system and transition from one state to another is accompanied by the emission or absorption of energy. This amount of energy is equal to difference in energy of the two states. Say this is electron, it is orbiting in this orbit, and there is another orbit corresponding to it. When a photon is made to incident on it, transition will goes from this level to this level, and say this is the energy level E1, this is energy level E2. So there is a transition, and that means the photon gets absorbed. And another possibility, if by some process an electron will be in this level E2, then there is a transition from electron from this to this, and there is a emission of photon. It is emission and it is the absorption. This is the geometrical representation. So h nu is equal to E2 minus E1, and here the photon which is absorbed is nothing but E2 minus E1. It is absorbed photon and it is the emitted photon. Then another postulate is the Bohr's frequency rule. The frequency of the radiation emitted the frequency of the radiation emitted by a system on transition from an initial state of energy E2 to final state of lower energy E1, or absorbed on transition from the state of energy E1 to that of energy E2 is given by that nu is equal to E2 minus E1 by h. The third postulate, it's the second postulate. Let me talk about the third postulate. Stationary orbits. These stationary orbits are attainable attained at a distance for which angular momentum of the revolving electron is an integral multiple of h upon 2 pi, or you may call it as h cross, or you may call it as h cross in this way, and this is known as reduced Planck's constant. Reduced Planck's constant, that is MEVR. If it is orbiting in the nth electron, then it is NH cross. Rn is the radius of the nth energy level. And this idea of Bohr's condition that angular momentum is n whole number multiple of h cross was later reinterpreted in 1924 by de Broglie as a standing wave condition. The electron is described by a wave and a whole number of wavelength must fit along the circumference of the electron's orbit. And this condition is written as mathematically that n lambda is equal to 2 pi r. Next, I will talk about that Bohr's quantization condition. Bohr's quantization condition leads to explanation of spectrum of hydrogen atom. So let us talk about that in detail. Now, since electron is revolving around the nucleus under the influence of Coulombic force, this nucleus and this is electron. So for hydrogen atom, one proton is sitting here. So charge on it is plus E and minus E charge will be here. There is a Coulombic force. And the Coulombic force is balanced by the centripetal force. So that means this Coulombic force E square over 4 pi epsilon naught r square is balanced by me, mass of the electron, me v square upon r. So this is centripetal force and this is the Coulombic force. So both are balanced. Right, so let me call it as equation number 1, or I can say, let me go back and let me call this as so let me call it as equation number 1 and this as equation number 2, and the next I will call it as equation number 3. Now, Bohr's postulate suggests that angular momentum is equal to me dr, and it must be integral multiple of nh cross. It is integral multiple of h cross. So this I have taken from equation number 1. I used it here. So from here, velocity comes out to be nh cross over mer. Therefore, v square will become, because I need this value, so that means v square is equal to nh cross over mer whole square, and I am interested to calculate v square by r, so it is 1 by r. So it is n square h cross square me square r cube, which can be written in this form, and mev square by r, it comes out to be me n square h cross square over me square r cube. So this will cancel out with it, so it is n square h cross square mer cube. Right, so if I use equation number 3, then equation number 3 will become using this, that this is E square over 4 pi epsilon naught r square is equal to n square h cross square over mer cube. This r will cancel out with it. So that means E square over 4 pi epsilon naught n square h cross square mer. So from here I can calculate the value of r. So r comes out to be, I bring it towards this side and this towards that side. So this divided by me e square into n square. So this is the radius and it's a function of n. So that means this r can be replaced with rn. radius of nth orbit 4 pi epsilon naught h cross square mee square into n square, and let me call this quantity as a naught, so it is a naught n square, or I can call it as n square a naught. So let me call it as equation number 5. So it's the radius of nth orbit, and here the quantity a naught is equal to 4 pi epsilon naught h cross square over mee square. It is known as 0.053 nanometer, or it is 0.53 angstrom. It is known as Bohr radius. Bohr radius. Now let us calculate the speed of electron in nth orbit. Speed of electron in nth orbit. So again consider equation number 1, and from equation number 1, as we know that me, b and rn is equal to nh cross. This n basically with v and the r simply represents the velocity in the nth orbit and the radii of the nth orbit. So from here, the velocity in the nth orbit, it comes out to be nh cross upon me rn, or h cross over me into 1 over rn. It can be written in this form, and 1 over rn comes out to be mee square over 4 pi epsilon naught h cross square into 1 over n square. So if I put its value here, then it will become nh cross me, and its value will be mee square over 4 pi epsilon naught h cross square 1 over n square. So we'll simplify it. So this h cross will cancel with it. This me will cancel out with it. So it is e square, and this n with this n. So it is e square over 4 pi epsilon naught 1 over nh cross. This is the velocity of the electron in the nth orbit. Now let us calculate another very interesting parameter, that is fine structure constant. And this fine structure constant is a dimensionless quantity, because it is basically the speed of fine structure constant alpha is known as velocity in the first orbit divided by speed of light, and this is the ratio of two velocity terms. So that means it is a dimensionless constant, and it is e square over 4 pi epsilon naught 1 over h cross for first orbit using this equation into 1 by c, and its value comes out to 1 over 137. Also v1 is equal to alpha c, or 3 into 10 raised to power 8 into 137, and it is meter per second, and its value comes out to be 2.19 into 10 raised to power 6 meter second. So that means the electron is revolving with this velocity in the first orbit. Now let us calculate total energy of the electron in the nth orbit. So that means now I will talk about total energy of the electron in the nth orbit. So total energy E is nothing but it is the kinetic energy plus potential energy, and kinetic energy is half MeV square plus minus 1 over 4 pi epsilon naught E square by R. So it is the potential energy, right? So using equation 3, that MeV square by R is equal to E square over 4 pi epsilon naught R square. As we know, this R will cancel out with it. So MeV square is equal to E square over 4 pi epsilon naught R. But I am interested to calculate MeV square. It is 1 by 2 E square over 4 pi epsilon naught R, right? Let me call it as, and using this value in this equation, right? And if I substitute its value, then E will be equal to 1 by 2 E square over 4 pi epsilon naught 1 by R minus E square over 4 pi epsilon naught 1 by R. So if I simplify it, so it is 1 by 2 E square over 4 pi epsilon naught into 1 by R, and with a negative sign. That's what I am getting. So let me call it as En, energy of the nth orbit. So for that case, this En can be written as in the similar manner, minus E square over 8 pi epsilon naught 1 over Rn. And if I substitute value of over 1 over Rn here, so it is E square over 8 pi epsilon naught into MeE square over 4 pi epsilon naught h cross square and 1 over n square. So this after simplification will become minus Me over 2h cross into E square over 4 pi epsilon naught. Its square is 1 by n square. So that means this En is basically equal to this one. And let me call it as R over n square minus R over n square. And here I have chosen that R is equal to Me over 2h cross square E square over 4 pi epsilon naught whole square. And this we call it as 13.6 electron volt. And what is it? This is Redwood constant. This is Redwood constant, and it is derived using Bohr's postulates. Now let us try to explain the spectrum of hydrogen atom. Next, I will try to explain using this formulation the spectrum of hydrogen atom. So the formula which we got from this is En minus Em according to Bohr's postulates. So this is the energy of the emitted radiation if N is greater than M. So let us try to define this is equal to, so it is R over N square minus R over M square, and this we call is R 1 over M square minus 1 over N square. Now let us try to explain various lines which we are getting in the hydrogen atom spectrum. So first of all, I will talk about Lyman series. before moving towards that, let us try to explain the electromagnetic spectrum. So for that, this is electromagnetic spectrum, and I will divide it into various parts. There is one point which I am getting here, and another point I am getting here, and this is, and so on. So let me call it as this point is basically 0.00124 electron volt, and this point is 1.65 electron volt, and let me call this point as 3.26 electron volt, and this whole of the region is up to 124 electron volt. Now this is ultraviolet region towards this side, and this is visible region, and this is the infrared region. Right, so this is infrared region. So keeping this in mind, I will explain various series and in which region those series will lie. So first of all, I will talk about the Lyman series. For Lyman series, must be equal to 1 and n must be equal to 2, 3, 4, 5 and 6. So that means if from second to first transition or third level to first transition or fourth level to first level transitions, these all are comes under the Lyman series. So the frequency corresponding to this is represented as h nu L. L represents the Lyman series, so En minus E1. Right, so it is R 1 over 1 square minus 1 over n square, and here n is greater than 1. So this equation represents the Lyman series, and this is 13.6 into 1 minus 1 by n square. So h nu Lyman series, if there is a transition from second to first level, then it is represented by this. So it is 13.6 into 1 minus 1 by 4. So it is 10.2 electron volt. Right, and similarly h nu L 3 to 1 level transition, it is 13.61 minus 1 by 9, and its value comes out to be 12.09 electron volt. And h nu L 4 to 1 represented by 13.6 into 1 minus 1 by 16 is equal to 12.75 electron volt. So it is ultraviolet region, because all are lying in the ultraviolet region, as is clear from this spectrum. Right? So from 3.26 to 124 electron volt, this whole of the region lying in the ultraviolet region. So that means Lyman series, the spectral lines which are observed in the Lyman series are all lying in the ultraviolet region. Then after the Lyman series, let me talk about the Warmer series. So for the Barman series, there is a transition from n is equal to 3, 4, 5, 6 to m is equal to 2, right? So it is h nu b, it is represented as En minus E2, and it is 13.61 by 2 square minus 1 by n square. So it is 13.61 by 4 minus 1 by n square. It comes out to be in electron volt. So that means h nu b 32, h nu b 42, h nu b 52, h nu b 62, and h nu b 72. Up to 62 I think is sufficient. Okay, h nu b 72. So here let me find out the energy of all these. 13.61 by 4 minus 1 by 9. Its value will be 1.89 electron volt, and it is 13.61 by 4 minus 1 by 16, and its value will be equal to 2.55 electron volt, and it is 13.61 by 4 minus 1 by 25. It is equal to 2.856 electron volt, and here it is 13.61 by 4 minus 1 over 36 is nearly equal to 3.02 electron volt, and here it is 13.6. 1.4 minus 1 by 42 is nearly equal to 3.12 electron volts. So these are the 5 colors which we are observing, and all are lying in the visible region. And this corresponds to red color, this corresponds to green color, and this energy corresponds to blue color, and this is nearly purple like color, and this is the violet color. And this is also clear from the diagram, and let me go there. So if you go to here, so it is a spectrum of hydrogen atom. Wait. Yeah. So these are the lines which I am getting. Right. So this is red color, this is green, this is blue, this is purple like color, and this is the violet color. These are the 5 lines which we are getting in the spectrum of hydrogen atom. This is the wavelength range, and this is the energy range, right? So that means this Bohr model was beautifully able to explain the spectrum of hydrogen atom. Then there is another series, that is Bastion series. So Bastion series resulting from m is equal to 3 and n is equal to 4, 5 and 6. So that means h nu p, it must be equal to En minus E3. So it's equal to 13.6 into 1 by 3 square 1 by n square, and it is equal to 13.6 1 by 9 minus 1 by n square. So that means h nu 4 to 3 is equal to 13.61 by 9 minus 1 by 16, and h nu 53 is resulted 1 by 9 minus 1 by 25, and this is h nu. This is 1 by, sorry, it is 6 minus 3, 6 dash 3, it's 13.61 by 9 minus 1 by 36. So these after calculation comes out to be 0.661 electron volt and 0.967 electron volt, and here it is 1.133, and all these are lying in the infrared region. So let us understand all these in a energy level diagram. So let us draw energy level diagram. It's just an estimation, so they are not properly scaled. So here is n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, and n is equal to 5, and n is equal to 6. And energies corresponding to these levels, that E1 comes out to be minus 13.6 electron volt, and here E2 is equal to minus 13.654, because it is inversely proportional to n square. So it is 3.4 electron volt, and E3 is minus 13.659, and it's nearly equal to minus 1.51 electron volt, and E4 comes out to be minus 13.616, and it is minus 0.85 electron volt, and here it is E5 is equal to minus 13.6525, and it's nearly equal to 0.54 electron volt, and here E6 is nearly equal to minus 13.6536, so it is nearly equal to 0.378 with a negative sign electron volt, right? So this is energy. So now let us apply transitions. And one transition is possible from this to this level, this to this level, this to this level, or so all these transitions means up to the first level. These all are known as Lyman series. Right? And all are lying in the ultraviolet region. And another transitions are possible due to one possible transition, there is another possible transition. So these transitions are possible due to these transitions, right? That means if from n is equal to 3 to 2, there is a transition 4 to 2 and 5 to 2 and 6 to 2. And as we see that all these are known as warmer series. And these all are lying in the visible region, as we have calculated. So this is observed in experimentally also. There is a another possibility. Third possibility is that this one. There is a third possibility, right? And we call these as Bastion series. And they are lying in the infrared region. So this is all about the spectrum of hydrogen atom. So we observed the things in the same manner as we have observed experimentally. So this is the first attempt, Bohr's model is the first theoretical attempt to explain the spectrum of hydrogen atoms. So thanks for watching this lecture.